So in this video, we're going to work through data visualization with ggplot2, which is again, a package within the Tidyverse collection of packages. This is all within R. Okay, so this slide is really to show you just the breadth and the power of ggplot. There are a lot of different ways that you can visualize data depending on what the message that you want to invoke, as well as the data types, the data in which you have. Just working from left to right here, the left top figure here, this is a box and whisker plot or a box plot. And that shows you the spread of data across different groups here at the bottom. Next, we have here in the middle, top middle, we have bar plots, but they're stacked and they're color coded based on these categories here. This plot, we're seeing a scatter plot. We're seeing these points here, but they're also mixed with these lines, which seem to be trend lines across these different groups, these classes here. Again, we're seeing scatter plots here, but now we're seeing the use of color, continuous color, as well as shapes to indicate differences in city miles per gallon, as well as drivetrain across these two different variables in 2 different years. So this is what's called facet wrapping, which we'll use. So it's showing the same thing, but across 2 different years in this case. Another scatter plot here. We're seeing the use of colors to indicate, I'm assuming, different measurements within different months. And then finally, what's called a ridge plot. So this is a really powerful and very informative figure that's showing distribution in bottom temperature here across months. So we're able to see the distribution within each month, and the use of color is showing us just another way to indicate temperature as well, to make it easier on us to view temperature here. We're also seeing a vertical line here that's giving us the average temperature across the data. So again, this slide here is really just to show you the breadth and power of ggplot. I am such a fan of this package and way of visualizing data, use of visualizing data. Okay, so we're going to work through this package like we have with the other Tidyverse packages, but we're also going to spend a bit more time going through how you can start to manipulate your code to format it the way you want, because there's again, you have a lot of power within ggplot. So first and foremost, the purpose of ggplot, it uses what's called grammar of graphics, GG, to create plots that accurately visualize data. A quote from Wickham: a statistical graphic is a mapping from data to aesthetic attributes, whether that's color, shape, or size, of geometric objects, which points, lines, bars. So that really is a great way to describe what ggplot is. And again, 3 most basic elements of a plot derived from ggplot. The grammar of basics is the data, what's called the geoms, and the coordinate system. So let's get into that. So we kind of worked through that that quote here at the top, but I've highlighted now the same 3 basic elements of ggplot. And here at the bottom, we're going to work through this list line by line in terms of how we can start to format and just like build a ggplot derived figure. But again, we have the data, we have the layers. This is where the geoms come in. So this is like, oh, I want a ggplot, or excuse me, I want a scatter plot, or I want a bar plot. That is the geoms. Any statistical transformations that's needed, that's where the stats are. So that's all within the layers. You can start to manipulate the scales, whether that's X and Y axis or its color. You can manipulate, you can choose what colors you use. That's where scale is. The coordinate system, that's fairly generic when it comes to tabular XY data, but this really comes more handy and more helpful when you start to work with spatial data, which we'll get to. Facets, I mentioned that earlier. That's when you're faceting across a variable because you want to show the same figure across, say, a group or years, what have you. And then finally, theme. This just is kind of like a catch-all of all sorts of themes that you or like edits you want to make to your figure. That could be font size, color of your font, and that's whether that's x-axis title or the text of your x-axis, the title of your plot, the legend, the title, the legend title. This is theme. That's all within theme. So we're going to get to that in a bit. Okay, so this is just a nice way to look at it as well. Again, kind of just layers on top of each other. We'll get to this in a bit more explicitly. So let's work through how our code would look to visualize some data. So you first call ggplot, and within this parentheses, the main argument is the data. So you'll just put your data set name where it says data here. When it comes to ggplots and the code to create a figure, I usually use separate lines for each like layer. It's really just common practice. And I think also, again, we don't want to make these lines way too long. And it just helps visually to understand where things are. So building on top of that first line, which is really just calling ggplot and defining your data, you're then going to start to, this is where you start to identify the geom. So the geom function, again, say we want a bar plot, we would say geom bar or geom call, COL. These are different bar plots. Geom histogram, or you want geom point, that's where you would put that there. Mapping, that is an argument that asks for the aesthetics. That is the X, the Y. Say you want color, this is where you would identify those variables that are your X and Y, as well as any sort of color, size, whatever sort of other aesthetic you're trying to show within your figure. The stat and position arguments, those are specific to just a few geoms, particularly bar plots. So that we'll get into that in more detail in a bit, or in some examples. So this is really what I just went through, but in your aesthetics, not only do you have X and Y, but you can also define color, line type. For instance, say you want different lines to be indicated, or different groups to be indicated by different line types. There's that. The size of the point, the shape of the point. You have a lot of power here when it comes to the AES, or the aesthetics. Okay, and we're just going to work through some of these geoms here. And this is taken from the cheat sheet for ggplot, which I will show at the end of this video. But say you just have one variable and it happens to be continuous data. Here are some of the geoms that you would use. The one I use the most is geom histogram or geom bar, but geom bar is discrete. So these are super powerful to understand. The main purpose of these are to understand distribution of your data. So I really stick to geom histogram. Okay, so to the right here, we're seeing now geoms with two variables. Lots of different options. I think I've identified those that I use the most when it comes to both one variable, but in the two variable area, we have geom point. So that's your basic scatter plot. There is a geom smooth here. So that allows within ggplot, you're able to create these trend lines, and you can identify what sort of trend line you'd like. This is by using the argument method, using what's called LM is just a linear model, but you can indicate what other sorts of models you wish to run. And you have a bit of power there in terms of confidence interval and what have you. Again, this is where it would be helpful to use the question mark geom smooth. just to get some help on the function. But again, geom smooth allows you to create trend lines within ggplot. Geom text allows you to label, say you had points, you did scatter plot or geom point, and then you wanted to add text to each of those points. You can use geom text to then label those points. Another great one is geom line. You can create time series data. Up here at the top, that's more continuous bivariate distribution data. I don't really touch those as much as the ones that I've boxed here. Here at the bottom, we have discrete and continuous data. This I use a lot as well. So we have the geom call, which looks very similar to the geom bar. And then there's also the geom box plot. So that's that box and whisker plot we saw to look at the distribution of data across, say, for example, groups. And then geom violin, which is another great way, I think, better way to show your data as opposed to geom box plot, because these violins show the distribution of your data at a given variable or value. So not only does it show like the spread of your data, but it shows the distribution, which you don't get in the geom box plot. So really, really powerful when it comes to different geoms within ggplot. Okay, so now that we've called the data, we've identified the geom we want, and I mentioned, hopefully you caught on, but I mentioned that you can build on top of each other. So you can have a geom point with some lines and label the points. That's 3 geoms in one figure. And you would just, one after another, you would have each one. Okay, so after you've indicated the geoms, you next indicate your coordinate system or your coordinate function. Again, as I mentioned earlier, this is pretty generic. You don't really need to indicate anything here when it comes to tabular data. This comes way more handy and helpful when it comes to spatial data. So this is pretty, whatever is the generic or kind of assumed coordinate function, it's usually fine for tabular data. But this is just to show you just some examples. I think if anything, you might want chord flip. If for example, you wanted to flip your axes over, that's really the only one I really use when it comes to tabular data. Okay, so scale. This allows you to control how data maps to visual properties. So ggplot has well-selected defaults, but often customization is needed. And there are several ready-to-use scales for different types of aesthetics. There are color palettes out there that are amazing. And you can have a lot of fun with them and get lost in them. So this is where you can really start to play with, have a lot of fun with how you want your figures to be visualized. So this is some examples of scales. On the left here is those generic scales. So again, this is taken from the cheat sheet. The most generic scales, you're usually identifying scale, and then there's a star there to indicate either X or Y. So scale X continuous, if you have a continuous X variable, you can, within those parentheses, you can start to identify the limits, the breaks, like how you, say it's time, you have 1990 to 2025, and you want it by each year. That's what you would put in scale X continuous. Manual allows you to have full customization. So scale X manual, scale Y manual allows you full customization there. Okay. Apart from just like identifying the scale for X and Y axes, you can also start to identify the scale for whatever sort of other aesthetics you use, whether that was fill, so the color within a bar plot, or the color of your points, whatever you used in your geoms, or your aesthetics within your geoms. So this is where you can play with the colors So scale, fill. These are some just generic ones again. Distiller, gradient, those are functions. And then within that, for example, distiller, you can feed it this palette, and there's just hundreds of palettes that you can use. You can create your own palette from a gradient from red to yellow, assuming that this variable you're working on is continuous. Again, you can also do scale, fill, manual, which gives you full control over the colors, and you have to indicate each and every color and what group that goes to. So you can have a lot of fun and also spend a lot of time just here working on your figure. Okay, so this is, I just wanted to show you fill manual. In this case, this could be color, this could be shape, but in this case, we're doing fill. And I use manual the most because I want full control over what is being done with my data and how it's being visualized. So within the scale fill manual, you are usually, the arguments that it's asking for are values, limits, and names. So values are the range of values to include in mapping. So that's everything you see. The limits as well, the breaks help you to use or what are being used in the legend or the axis. The name allows you to, oh, I missed a few, but the name allows you to indicate what the name of this legend will be. So that the legend name should be fuel. And then the labels are what you see in the legend, as well as the axes. Okay. Okay, so lastly, there is the theme function. And this again is where there's some generic themes that you can use, but this is also where you can customize other sorts of aspects of the figure. So here are some generic themes. I tend to use theme minimal, or theme black and white, or classic, and it just depends on like what you prefer, whether you like grid lines in the back or whether you prefer white space. It just kind of depends. But yeah, I tend to use a theme underscore black and white or theme underscore classic. And then under that, I will also, using theme, start to identify axes title size, axes title text, color, mainly text size and text color. Plot titles, if that's something that you wish to do, that is all within theme as well. Okay. And then finally, faceting. So this is when you want to facet over a single variable. So this is an example here. I'm sorry it's so small, but this is a generic data set within R. And this is showing miles per gallon versus weight. And it's over this group here of 4-cylinder, 6-cylinder, and 8-cylinder. So it's showing for each group, it's showing a scatter plot of these two variables. So that helps you to compare across this group, which is really helpful. So that's what faceting, facet underscore wrap is the function. And within this, you would put the variable in which you wish to facet over. So here's an example of facet grid now. So that is faceting over multiple variables. So here we have a group up here along with, a variable here as well as a variable here. So it creates this really nice, almost like pairs plot that we saw earlier or worked through earlier. But it gives you, if you have a lot of variables to look at, you can start to see, is there any correlation across these different groups? That's facet underscore grid. Okay, so that wraps up what we're going to work through with ggplot. Here again, as promised, is the cheat sheet for ggplot. We actually worked through a lot of this with the slides, but I am constantly referring back to this to help. It's hard to remember everything and what each of these geoms or each of these functions require in terms of arguments. So I'm always referring back to this cheat sheet. It's quite helpful. And there's the link there at the bottom.